My dad, Dean Koenig, started Starizona, so it was always just something in the house. There was always a telescope on the floor, ready to go out that night, or he did a lot of free solar viewing when I was younger too. So it was just something that I was just kind of around, getting dragged to star parties and stuff like that.
Welcome to the Cosmos Safari podcast presented by Celestron. In this episode, my co-host, the Last Minute Astronomer, and I invite Starizona to talk about their products, specifically the development of the Hyperstar accessory, allowing astro imaging up to f2. I'm Dave.
And I'm Rob, the Last Minute Astronomer, and this is the Cosmos Safari podcast. And today with us, we have Steve Koenig and Scott Tucker from Starizona. And Steve and Scott, tell us a little bit about yourselves. Introduce yourselves to the audience.
Hey, thanks for having us. We really appreciate it. We work in sunny Tucson, Arizona at Starizona. It's a retail shop and manufacturing of astronomy goods and accessories. We like to focus a lot on astrophotography, but we do visual still, and we're just general, astronomy hobbyists, geeks, somewhat professional, and it's more of an obsession. So we might as well get paid doing what we are obsessing over. So Scott does optics at Starizona, optical engineer.
I do most of the optical design of the products that we make, and it is just a hobby gone crazy. So it's, we think about what would we want to use, and other people might like and stuff like that.
Yeah, sure. Yeah. So
Fantastic.
adult. That's not going to sound right. I was going to say adult toy players, but you understand.
We hear this a lot from, having these conversations with people, is just how they've kind of tried to morph their personal interest into something that they can do every day. And it's awesome. So congratulations on kind of being able to do that. That's kind of the dream, right?
Yeah, it's definitely the dream.
Where did your love of astronomy and astrophotography start? Like, where did that come from?
You want to go first?
Yeah, I mean, I was always interested. I grew up in Michigan, which is terrible for astronomy, but I moved to Arizona to go to the University of Arizona for astronomy. Tucson's such a good place to stargaze that I got into it, and just have been working at Starizona forever now, and have just, been obsessed, and so always been interested in it.
Yeah, and my dad, Dean Koenig, started Starizona, so it was always just something in the house. There was always a telescope on the floor, ready to go out that night, or he did a lot of free solar viewing when I was younger too. So it was just something that I was just kind of around, getting dragged to star parties and stuff like that. I would say it became more of my passion when I started going to college, took my first astronomy course, and then I think it really clicked for me when my first astrophoto ever was a Canon T3i with a T adapter on the back of a GPS 11 Alt-Az, sent it to Orion, and I took a 25-second exposure, probably like 1600 ISO. It was noisy and ugly. And by any means, by today's standards, it was just like not a photo. But you start seeing green and the trapezium, and you're like, whoa, did I just discover the Orion Nebula? You just get so excited. So that was, I think, that first thing. So I got into photography first, and I just knew about astronomy. But when I connected those two is when it was really, obsessive.
Yeah, I can agree. Like, one of the first, in fact, this picture back here is my first picture of the Orion Nebula. And like you said, by all means, not that great of a picture anymore. But, based on what I had at the time, that was really good. And I still love it, even though it's, kind of trash, but
what it represents, it's cool.
The Canon T3i is where I started as well, and Rob, I believe you use a Canon T3i at times also. Yep. It's a great camera, and for those of you just getting started, if you haven't kind of jumped into this quite yet and are interested, I know that they're now older, but they still do a decent job, and it's a great place to start, especially if you can get it on the used market.
I love that flip LCD screen. That was my favorite part. But
I actually started my first astrophoto was probably with a film camera. And I think I just pointed the 50 millimeter lens camera on a tripod up at Orion and took a picture. And there's like the little pink glow of the Orion Nebula. And it was just amazing. And so, I started at the sort of the tail end of film photography. And so it was definitely the hard way of doing it back then.
Yeah,
I believe it. Kudos to you.
Yeah, when I met Scott, he was guiding with looking in and manually guiding on your
crosshair
star
eyepiece
with film.
Wow.
And then you send it
crazy.
off to your local film place and hope it was in focus when you get it back next week.
And it wasn't always, no.
Right. I love the instant gratification of digital. It's fantastic.
It's changed everything, yeah.
And for just learning, you're going to learn so much. Change your ISO, instant feedback, so you know what that.
Yeah, it's so much easier for people to learn it now and get into it and enjoy it, and not just hate every second of it.
Will Dave survive last-minute trivia against Team Starizona? Find out after this short break.
Introducing Celestron Origin, stargazing and astroimaging redefined. Origin is completely autonomous. Simply choose a target in the app. Origin captures it with ultra-fast RASA optics, perfects it with AI imaging processing, and delivers it to your device. The results are better than what you'd see in a much larger telescope under much darker skies. Experience and share the night sky like never before. Learn more at celestron.com/origin.
Now, before we go a little bit further, I have a little bit of trivia for all of us on the call. Dave doesn't know what we're doing yet, so
Nope.
But we're gonna let the guests. We're gonna have you guys answer first, and then I'll have Dave answer. I've got 3 questions, and we'll see. When I was looking this stuff up, it was not the easiest stuff, so we'll see what happens here.
Wonderful.
So let me ask you this first question: When was the first SCT, Schmidt-Cassegrain telescope, of course, because we're going to be talking a lot about that today. When was the first SCT manufactured?
Do you mean mass-produced manufacture, or just
the very first one? I would say.
You want a specific?
Not for commercial use. It wasn't. I'll give you that hint. It wasn't for commercial use.
Okay.
I'd be guessing something in the.
I'm gonna
before the
50s.
I was thinking just a little bit before the 50s, but
I'm gonna say. You want a specific year?
because
We have to guess
sure.
a year.
Sure.
Okay.
Well,
19,
yeah.
I'm gonna go 53.
Okay. What do you think, Steve?
I'm gonna do 52.
$1. Price is right.
Doing the
rules.
under.
There you go.
And I'm going to do 54.
All right. Well, it was actually about a decade earlier than that. The optical shop at the Mount Wilson Observatory manufactured the first one during World War II as part of their research into optical designs for the military.
No.
Yeah.
No.
So I don't have a specific year, but I would say 41, 42, 43, 44.
Yeah, because I think the Schmidt himself that
Yeah.
invented the Schmidt camera, I think, was in the 1930s, and he was worried about the design. He didn't patent it, I don't think, because he was worried about the design being used for military purposes, and sort of foresaw World War II coming. So,
Okay, all right. So not too far off, only a decade off. Let's go. Number 2. What or when? I'm going to give you 2 options here. What or when was the first large telescope to use the Schmidt-Cassegrain design? Like a research telescope.
Do we have the moon map one on?
it's not a Schmidt thing.
Oh, is that like an unclassified?
I mean, there are a lot of Schmidt cameras,
Yeah.
but the Schmidt-Cassegrain, I mean, I can't think of it. I mean, how large are we talking?
Ooh,
Just
that's a good
professional
question.
observatories, what you were saying, I think.
Yeah, I'll give you a hint. It's at a university.
Oh, okay.
Oh, that changes.
Yeah, that
You said what or where?
What or where or when? Sure. Or when or where.
Yeah, I don't know. Maybe the University of Arizona, they do a lot of optic stuff. I don't know.
Okay.
As far as when, I mean, I would be thinking probably in the 50s again would be about when I think that would be kind of
50s or
taking off
60s,
into maybe like moon map, pressure. There was a lot of interesting stuff at that time.
Yeah, I'm gonna pass on this because it's gonna be.
It does have an aperture of 37 inches.
What?
37-inch SCT. Current setup is actually only about 33 inches, it says. But the first large telescope was the James Gregory Telescope of 1962, which is at the University of St. Andrews.
Oh, cool.
So, yeah, it was recognized.
Where is that?
That is in, I believe it's Scotland.
Okay.
University of St. Andrews. St. Andrews, Scotland, yes.
What a great place to do astronomy.
Yeah.
Has it ever been used?
That surprises me. Why not in Arizona, right?
I think it's going to be promising.
They're still holding out hope they'll get to use it one day.
I'm feeling that multiple choice should have been in order here for some of these.
You're right. And it actually is also recognized as the largest Schmidt-Cassegrain right now. So now I've got a multiple choice for you. Okay. Number 3, last one, then we'll get into other stuff. What is the biggest mistake to make while using an SCT? Is it A, not taking the lens cap off? B, dropping it? C, taking it out in the first place because it's cloud bait? Or D, whatever Scott and Steve are thinking about right now?
D, not using a Hyperstar.
Yeah, that's right. Using it.
Great answer.
Product placement. Well done.
I mean, not taking the cap off is very.
Yeah, I mean, as far as like common mistakes, I don't know. I mean, fortunately, not too many people drop them, but it does happen.
Letting them cool down. They got a lot of air inside of them. They got to acclimate to your ambient temperature. In Arizona, that often means heat up, not cool down.
This time of year, for sure.
If you want better seeing, that would be some things. Double checking collimations, obviously important. But I mean, as far as the clouds go, it's like you miss every shot you don't take. So we're definitely sucker hole chasers over here.
Yeah, for me in Pennsylvania here, the dew shield or a dew heater is probably in order most of the year with our humidity levels. So that would have been my D. Okay. Is the need for some sort of dew prevention.
All right. Well, let me tell you, you all got it correct. Very good. Points for everybody.
Yeah.
Well done. So let's move on a little bit. One of the reasons that we have you on is to talk about Hyperstar. Could you tell us, I guess, first, like what Hyperstar is for audience members who don't know what it is, and then kind of tell us, how did it come about?
Mm-hmm.
Yeah. Do you want to do what it is and I'll do how? Maybe?
Yeah. Sure. So the idea is on a Schmidt-Cassegrain telescope, you can remove the secondary mirror from the front of the telescope and place the Hyperstar lens at the front, and you're using the f2 very fast primary mirror, and the Hyperstar corrects it, camera goes on there, and you have a very fast imaging system. It's 25 times faster than the telescope is natively with the camera at the back. Shorter exposures, wider field of view, easier deep sky imaging is sort of the idea behind it.
And a lot of people confuse it with a reducer, and it's not really reducing anything because your primary is already very fast. So it's really more it's a flattening, correcting device more than a reducer, because we're not turning F10 into F19. We're actually removing a piece of the system and flattening what's already there. So as far as its inception, though, Celestron had a huge part in that in making the fast star compatible Schmidt-Cassegrains. Back in the 90s,
late 90s, 2000-ish, there was
like
Schmidt-Cassegrains that had a removable secondary mirror, so that you could put, and originally Celestron did the Fastar lens that went on the telescope and converted it to f1.9 and gave you a very fast imaging system. But being that it was nearly 25 years ago, the camera technology is not what it is now. And so they're using these very early CCD cameras that were just amazing back then, because it wasn't film. It was something that was just, you had that instant gratification of digital. But very small sensors and slow readout times and things like that. And so as the technology of the cameras improved, the idea was to have the Hyperstar, improve optically and keep up with the larger sensors and stuff that were coming out.
And at the time, I think right when the Ultima 2000 came out, which is like one of the coolest scopes that Celestron made, which was your first go-to scope that you could actually grab and point to something else and manually move it, find something, and say, okay, yeah, go back to the other target.
It had encoders, so it would keep its position.
It was the first one that you could do both, use manually and use your go-to tracking system. And that was really exciting for us. And so the very first version of those, they weren't Fastar compatible, but they later released the removable secondary on that model. And so we would be doing this. I mean, when that first came out on the Ultima 2000, using like the SBIG 237, like tiny sensor. It came with let's see where my hands are. It came with like a briefcase sized computer and these huge serial cables. You couldn't even use it today if you wanted to, because it wouldn't connect to it.
Parallel cables, and it was like this, less than half a megapixel, and took like 12 seconds to read out, and it was just the greatest thing in the world at the time.
I think it was more like 28 seconds.
Yeah, something.
It was pretty rough. But I remember when that happened, my dad, he like lost 3 days of sleep straight. He he was so obsessed with the idea. Every night was just playing with it. And we're good friends with a local optical engineer by the name of Dick Bookroeder. And he's, if you know optical engineers, rock stars, he's like one of them. And at the time, Dean just like, hey, Dick, like, do you think this is, we're near the limit of what a Schmidt could do here in this type of, prime focus? And he was like, I think we could do maybe like 4 times better. And to that, my dad was like, whoa, well, can we play with that? And so between Dick Bookroeder and my dad, like machining and housings and optics and designing stuff, they came up with the first version of the Hyperstar, which was different in a few ways. One, it could be collimated, and then 2, we had different adapters for different cameras. And that was the thing that I think was hard to keep up with, especially at that time. More and more cameras were coming out, and being a small team, we could kind of stay up with making each new adapter for the right back focus for every camera that's kind of existed. So that was the start. And I think now, I mean, what would you say now, like our version 4 Hyperstar compared to the first one?
It's a night and day difference in the quality, because it would just, early on, the idea was you were designing for a very small sensor, and the design had to evolve as you get these bigger sensors. And some of the early Hyperstar 14-inch were compatible with DSLRs once digital cameras became a common thing. Had to cover this much larger field of view, and so the difference in the design between the first version and the current version 4 is pretty radical, and it's much better overall, and it's just evolved to keep up with that.
Steve and Scott discuss their favorite deep sky objects to image after this In Focus product spotlight.
The detail here is absolutely stunning. You can see the individual craters, the ejecta blanket, the white material that's coming out from the craters themselves onto the dark maria. Hey guys, I'm in the backyard with the Celestron NexStar 6 SE. This is one of Celestron's best-selling telescopes, and for good reason, because of its compact form factor and reasonable price point. The 6-inch aperture that you have here is good for things like the moon that I have behind me, which is what I'm going to look at in just a moment, and planets, as well as some of the deep sky objects you might be familiar with, like the Orion Nebula. Now, this telescope has over 40,000 objects in its computerized database. You'll be able to find any of these objects within just a few minutes. Before you do that, there is a red dot finder that it comes with up top, as well as a 25mm eyepiece. With that, you'll be able to first get your telescope aligned with something I would suggest during the daytime with the red dot finder, making sure what's in the telescope is aligned with what is seen here with the red dot finder. So to get started, all you have to do is you have to set up the index marks at the top of the scope here. There's two little arrows, you need to line those up, and then you simply flip on the telescope. And the 6SE does not have an internal battery, so I'm powering this off of a separate battery. You'll need that or AC power. And once you've got it fired up, you'll hit enter. And it'll ask you how you would like to align the scope. Now, because I'm looking tonight at the moon, I can actually go down to the option for a solar system alignment, and you'll be asked to put in the time, and if it's daylight savings or not, and the date. And then you'll simply select the moon or whatever planet you're looking for. And then once you've done that, you'll move the telescope so that it faces the object. Now, it's important to note that there is a red dot finder scope at the top of the 6SE, and you're going to want to make sure that you put that in alignment with the telescope's optics during the daytime on something that's at least 100 feet away or more. I like to pick out things that are easily discernible, something like a telephone pole, and that way when you're looking through this at night, the red dot finder and your telescope are already set up. I also suggest getting things in focus prior to it getting dark outside. It makes things so much easier. And there it is in the eyepiece. Nice. Now, if you're looking for something that's not a solar system object, there are 2-star alignment options, 1-star alignment options, and then there's the sky align option as well. All of these are great. They take just a few minutes to get things set up. You will have to get things set up correctly in terms of your site, your location, with the GPS coordinates to make sure that it's working properly, and just make sure that you're putting the time and date in correctly as well. Once you've got the object aligned, you'll simply press enter and then the align button, and the solar system alignment is complete. All right, so I've attached my cell phone to the scope. The detail here is absolutely stunning. You can see the individual craters, the ejecta blanket, the white material that's coming out from the craters themselves onto the dark maria. The maria are ancient lava flows that were formed in some of the larger craters of the moon, and they're famous. For example, the Sea of Tranquility is where we landed our first lunar landing. So hooking it up to your phone allows you to have that ability to just pinch to zoom. On many phones now, you'll notice that there are multiple different cameras, and so you're going to want to control which camera you're looking through. Sometimes it's difficult to do that. The phone wants to switch from one camera to another, so keep that in mind as you're using your phone's camera. That can be somewhat of a challenge at times. So if you're interested in doing photography, I highly suggest that you get one of these little Bluetooth controllers. This one has a setting for both iOS and Android. I simply turn it on. I find the Bluetooth in my Bluetooth settings on my phone. I pair it with this device, and now I can actually take an image. Right now I just took an image from this device, which means I'm not touching the telescope, I'm not touching the camera, and that reduces the shaking that you would otherwise see. So even if you're just tapping to touch, it does affect the image. You're going to want to take the image with one of these devices, especially if you're doing long exposures on something like a nebula, which you can do with modern phones. It's starting to become possible. There are some apps out there that you can take longer exposures, and even within the modern phones, we do have night sky mode, and you can try your hand out at that if it's a deep sky object. And keep in mind, all of the functionality that the phones come with, including tap to focus, which remember, your focus should really be being done with the telescope itself. And then you can also press and hold, and it'll create a little box, and you can adjust the brightness of the image right there on the phone. So that's pretty nice. You can really, you know, overexpose or underexpose an image if you're not careful. All right, everybody, I hope this video was helpful. If you have any questions, please leave them in the comments below. If you haven't done so already, please like this video and subscribe to Cosmos Safari. And as always, keep looking up, and I'll see you in the next video.
So for people who are kind of interested, they might already have even a FastStar compatible, you know, Celestron SCT. What kind of objects would you think this is like optimized for? Like what are the things that make the Hyperstar system kind of shine?
Yeah, well, I mean, because it's changing your focal length, say from like a 6-inch, I think behind you, the SE6, which is like one of my favorite little scopes there. But you know, you go from 1500 millimeter focal length to 300. So you know, we're going from away from planets and zooming in to smaller targets to a much wider field of view. So summertime right now, we call it Hyperstar season because you know the Milky Way is coming up. Anything coming out of Scorpio all the way up, every one of those nebulas is going to be exciting. Wide field of view, bright, and those are just things you aren't typically going to be getting inside of your scope.
You get the larger objects, the Lagoon Nebula and the Veil and the Rosette and the Orion Nebula, the Andromeda Galaxy, any of that big stuff that's hard to get with a camera at the back of the telescope where it's very small. And the fact that it's making it so much faster is you're getting that data in a shorter period of time. So for beginners, it's easier to do and take pictures and see stuff and get results right away. But even for advanced imagers, you can take these pictures that are quicker, and you just, you know, it's hard to go back after you've shot with these high-speed systems. But it also works well for people do a lot of comet imaging with it. You have a comet that is close, has a big tail, you have this wide field of view, and you have short exposures so that you can get a lot of data before the comet moves across the sky some significant amount. So it's actually good for a lot of different things in that regard.
And going back to the picture of Orion in the background there, I mean, that's a perfect example. You know, you take that same exact camera and you would put a Hyperstar on that, you know, C11, and all of a sudden you can fit all of the Running Man and Orion and more in that same field of view, same camera, same scope, but now we're just using the optics in a way that favors field of view. So that's just, you know, it's not that one way to do it is the correct way. It's just having another kit in the tool belt of like, hey, how am I going to approach this target? Do I want to zoom into just the trapezium, or am I trying to get some more context there? So I think it depends on what you're trying to achieve, but ultimately, wider, faster, and like Scott said, you learn quicker because you make a mistake. Well, that was a 10-second photo. You learn, oh, we're out of focus. It wasn't a 3-minute photo to say you're out of focus. So just that faster turnaround time is going to get you further down the road. Everything doesn't have to be as complicated, because we used to say our biggest thing was like no wedge, no polar alignment, no guiding, no kitting. That was like one of our first ads. And
that's great.
I mean, we put Hyperstar 6 on that SE mount, and people doing fantastic images just on that mount. That mount should not be taking astrophotos. It's a fantastic mount for visual, but that's not what it was meant for. But if you get a short photo, it works. It's great.
And that's what we love about the SCTs in general, is that you have that versatility. You can use the Hyperstar and get a wide field of view, and you can then switch if you want to shoot the planets. It's still a good telescope for that. It's one telescope that can do a lot of different things, and that's why they're probably one of our favorite telescopes.
Yeah, we call it like the Swiss Army knife of telescopes. She just does a lot.
Nice. Do you have a favorite target that you've gone back to time after time?
Time after time.
I mean, you know, when we do a lot of testing of a lot of different stuff. So it's like, you know, we've got tons of telescopes, and we're always testing different things and new versions of Hyperstars and things like that. And so you shoot the same object a lot of times with different setups, different cameras. You want to try a new filter and stuff like that. So I've probably shot 1 million pictures of the Orion Nebula, and it's still cool. It's still an amazing thing. And it sort of depends on the season. Obviously, it's a winter object. So now maybe you shoot, the lagoon or, something like that. But there's some objects that sort of never get old.
Yeah. I mean, I like 891, NGC 891, Edge on Galaxy. Whenever that's up, it's kind of like, I'm like, oh, I just have to every year. I'm like, I just got to get a good shot of that. Just
North America Nebula, Gamma Cygni stuff in Cygnus. That stuff's always good. So,
but, yeah.
Are you guys finding that these newer high megapixels, is a thing too now? The ability, because you are so wide field, to be able to zoom in, digitally crop in now with high megapixel cameras, is that a game changer for you guys? Is there anything you have to kind of accommodate as a result of just the change in that pixel size? I know it's a fast telescope and it's going to gather light, that much faster. You can get away with smaller pixels, right?
Yeah, and you can, and that does help in the sense that one of the things the Hyperstar is not great at is smaller objects, galaxies, things like that. And so people find, that when those objects are out, that you can maybe put the camera at the back of the Schmidt-Cassegrain, you get more magnification, but that makes it harder. And so people love having image at f2, and so the smaller pixels get you better resolution so that you can shoot smaller objects still with the Hyperstar and get the speed, the advantage of that, and get the wide field, and you can crop in and get smaller objects at the same time. And it does change, the optical design has to improve, and that's happened with, digital cameras. Canon, Nikon, Sony, they've had to change their lenses over the years. As the pixels get smaller, the lenses have to be better. What was good 20 years ago isn't so good optically now. And so the Hyperstar is involved in that sense too, to accommodate those smaller pixels. But yeah, it has changed a lot. It's helped quite a bit.
Well, I was going to say it's more gone in our favor. So, I mean, one of our biggest selling cameras back in the day was like a Starlight Express H9C, which is still like a fantastic, CCD camera, but it's like a 9 micron sensor. Like the pixels are 9 micron, which are huge. And so while we're getting gorgeous, wide fields of view, we weren't maximizing the resolution, meaning the camera was not seeing the resolution the scope was producing. We were under sampling there. And so as pixels, we're trying to get them into our phones. So pixels are being driven down smaller and smaller and smaller. So what's happening is that shorter focal lengths are, in a better place than they've ever been. And we're actually seeing in the industry, it's kind of harder if you come in with an RC and you're like, hey, get me a great pixel pairing on this. And it's like, it doesn't really exist in the CMOS world. You'd have to go into the CCD to accomplish that. And really, there's just not new CCDs being developed. So you're working with generally a little bit older system. That doesn't mean it's bad or anything like that, but you do have to be mindful of the industry outside of astronomy is pushing pixels smaller. And so the scopes in the future are going to have to be faster and larger aperture. And so I think faster and larger aperture is just makes sense with a Hyperstar. So I think that's where we're probably going to be seeing, trends of scopes in the future as well.
Yeah, definitely.
Okay. If just for not to get into the weeds too much, but could you bin and have a similar result with multiple pixels being combined?
You can
resolve that.
Yeah, and the way CMOS cameras bin is different than the way CCD cameras did. It's done in the software side of it and not in the hardware side of it. So you don't gain the same amount of sensitivity, but there is still an advantage to it, and people do that, and it's a reasonable way to do it. But since it doesn't have quite the same advantage, I think Steve's right that the future of telescopes is going to be shorter focal lengths but bigger apertures, faster systems, so that you get that resolution like you used to get with a very long focal length telescope, but with the modern cameras and doing it with the faster telescopes.
And like Scott was saying, CCD binning is on the chip itself, and so it literally is becoming a 1 pixel, whereas it's more like a digital zoom in post kind of a thing. So it's not correlating exactly the same way. So your sampling is not going to have all the same benefits you really would have gotten by binning a CCD sensor.
And then one last question that kind of related: color or mono? What do you feel that? I realize that there's benefits to the mono and especially narrowband type imaging, but what do you guys find yourself landing? Most customers are doing these days. Is it color or mono?
I mean, color is much more common. We find it's much simpler for beginning imagers. You don't have to mess with a filter wheel and different filters and more processing and stuff like that. You get a more instant result. And one of the advantages that used to be to monochrome was for like narrowband imaging. You'd shoot H alpha to get hydrogen emission and then nebula. You shoot O3 to get oxygen. And now the filters that exist have changed that. You can get dual band, tri-band, quad band filters that isolate those, and you can use those with color cameras. And technically you're losing something because the color sensors have less sensitivity. You're not using all the red pixels for red and all the green, or all the pixels for green. And so there's technically some disadvantage there, but if you look at the results, the pictures, it's just the differences are not night and day for a lot of difference in cost and processing time and things like that. So far and away we sell more color cameras because that's what most people are doing. And there's nothing wrong with a monochrome camera and doing that, but we find that many more people are using color and getting amazing results.
And that might be our neck of the woods too, since we are really into the fast imaging. And I think with advances in, astrophotography photo processing, with like PixInsight and a lot of amazing tools out there these days that are leaps and bounds every year. There's like these new tools, they're just blowing people away, and you're getting amazing changes in just like how we're interpolating that pixel value around a pixel. How do we determine what those values really are? And it's been amazing. And so we have done some tests between mono and color, and the kind of school of thought was, hey, well, if I can use all 4 of these pixels in array for my monochrome, but I'm only using, say, a quarter of that for my green or blue, or half that for my green and a quarter for the blue and red, then it could be that I'm kind of losing part of my train of thought here, but it is that we used to say, it'd be 4 times better, the resolution for monochrome. But in reality, in what we've been determining, when you're done processing your photo, it's about 1.6 times higher resolution, as opposed to like this 4 times from a CCD is where we kind of got these numbers. But when you actually using modern processing tools, it's not as huge of a difference. But it does depend on what you're trying to do. If it's science-based, or you're really trying to isolate something, then there could be a lot of great reasons. And we personally use monochrome, but I would say the majority of our stuff is probably color, focusing on the beginner mostly. But then again, if you just go to Astrobrand, you search any mono camera, you're going to see people do amazing photos, and some people do just some all right photos. And you'll see that it's really the person's processing that's making the hugest difference, not necessarily the hardware they had at the time. So
personally, I have both monochrome and color cameras, but I shoot with the color camera much more often because it's just more convenient, and I'm not disappointed in the results. So
there you go. Not bad. Now, I was reading online a bit. Did I hear that you have a Hyperstar on the International Space Station?
It's no longer up there anymore, but it was on the iServe mission. Yeah, we specially designed a CPC 9.25 for the Wharf window. So it's a very heavily modified CPC.
What's CPC?
CPC is a Celestron Alt-Az telescope. If you go to celestron.com and you type in CPC, you're going to see a great line of telescopes that Celestron sells. But anyways, they are awesome, and so does Starizona sells them as well. But they're like a fork arm GPS unit in them. Although they didn't use that, we're basically using it as a robotic arm in this window to take pictures of Earth using the Hyperstar. And so we were reached out to by the iServe folks, and we got to work with them for a better portion of a year. It was up there for a while, but our involvement was about a year on the ground, making 3 different units, one for them to send up, one for them to break, and one for them to have as a model down here. And so we made like an auto-focusing system for them, and we got the Hyperstar on there. So yeah, it was awesome. Really, really cool. Sweet.
That's quite an honor. Congratulations.
It's pretty cool. They had it pointed back at the Earth to take images, the idea was the space station is moving 17,000 miles an hour, so it's not over any part of the Earth for very long. If you're trying to take a high resolution picture straight down towards the Earth from 250 miles up and get some decent resolution, you need a very short exposure to stop the motion that you're getting. And so the advantage of the Hyperstar was you could have this, pretty good resolution with the large aperture of the telescope, but use very short, they were using like 8,000th of a second exposures to sort of stop the motion of the space station as it passed over what they were trying to image.
Now, were those pictures taken by astronauts, or was it more mechanical and controlled by a computer program?
Astronauts.
Okay.
Nice.
Mm-hmm. And the astronauts did the installation and put things in there, and then
it's a really cool process because something we didn't know ahead of time is that when you send any equipment up to the station, you can't talk to the astronauts. I mean, obviously, but mission control is not going to be like, hey, grab that tool and put that screw here. You have to write instructions that are just so accurate, and you are not allowed to talk to them unless they ask you a question. And then if they say, hey, we're confused how we're supposed to do this, then you can answer a question.
Otherwise, they're following the instructions and putting it in there.
You just have to watch a video of them assembling everything and just being like...
And it's fantastic to see this telescope just floating by as they're putting it in there.
And
so it's shooting through the window, though.
Yep.
I mean, is that taken into consideration when you're designing the optics? I mean, is that part of the special...
We didn't have to. The window that they use is this wharf window, they call it, and it's a special optically designed,
interesting,
like $500,000 window, optical piece of glass. So it was like you don't. One of the goals was whatever you put in this little bay where it looks through this window has to not touch the window. The window is expensive; you can't scratch it or break it.
Yep.
And if you just search NASA wharf window, there's some YouTube videos of them explaining how they put stuff in there, and it's a really cool.
It's pretty cool.
It's a really cool thing.
That is neat. I'm very jealous. I don't have anything on the ISS. So.
No.
Can you tell us a bit about how many people does it take to make something like this, and what do those people do, and how does that process work?
It probably takes more people than we have.
Yeah, it takes more people than we have. We should not be doing this.
Yeah.
Our whole entire team is made up of 6 staff members, and including us, and our machinist here in town. And so between all of us, in even Diana Poloni, David Klein, Uriah Harrell, everyone there, by just being users of telescopes, and we do star parties very frequently, and we used to do them 4 nights a week. Wow. And we'd use those as test sessions to understand how our customers interacting with products that Celestron makes, that other companies make, and are we seeing something that every customer is having an issue with? Well, maybe we should try to solve that problem. And so we make a lot of accessories for those things just from our sheer use and seeing, one customer comes in, I'm having trouble getting my scope on my mount. We made the landing pad, and that was the first thing we ever really made. And then that was okay, now we're getting into machining. And then that turned into getting into optics. And Dick Bookroeder really, took Scott under his wing. And so Scott was kind of his protege, Padawan, if you will. And he's got one ponytail right behind here. You just can't see it. So a lot of it comes down to one of us has a crazy idea. And when the store slows down enough, because we have a retail store that if you walk into Starizona in 3 hours from now, I'm going to be there at the front desk saying hi, packing an order, answering a phone, working on a support issue or something. So we're a small team with a lot of hats. And so in between after hours, we just kind of all come together from that. Yeah. So
we're all people who use telescopes and do astrophotography and stuff like that. So we sort of know what we would want and probably what other people would want, and we do know what other people want because they tell us, and we learn what people are having trouble with and things like that, and try to make stuff that would help them and help us just for our own benefits. And if it's stuff people want and it's we can sell it, that's great.
Yeah, it sounds like a real organic process.
And sorry.
I said it sounds like a real organic process where
you're
you're really trying to build stuff that you would use and then selling that.
Exactly. And it's just, we see some interesting idea or a problem that we find a way to tackle that and make something. Steve's dad, Dean, the owner of Starizona, has always been very mechanical guy, and he fixes telescopes, and he fixes telescopes that probably have no right to be fixed, and he finds a way somehow, is just dedicated to doing this. And so he'll come up with an idea, or somebody will come up with an idea, and then Steve or I'll sort of do some mechanical design, figure that out. If there's optics, I'll look at that and see if there's ways to do that, and just keep iterating on it. Is there a better way to do it? And we'll have prototypes made and test stuff, and if we like it, it becomes a thing. If we don't like it, we go back and just keep making it better until it is.
I noticed that you're also selling some 3D printed products, and that's something that I know a lot of people are familiar with 3D printing. Do you find that has revolutionized your process at all?
100
single most significant technology that we've had. I don't know how we did anything before we had 3D printers. And literally,
we're surrounded by printers at work. We're surrounded by printers at home, and I think of a lot of our ideas as like, we just come in with something like, okay, so I had this idea this weekend, and this is what I made. What do you guys think? And they're like, let's go somewhere with that. And so I think every home should have a 3D printer. I think kids need to be learning how to making their own stuff. I think it's really getting anyone to start thinking about things in a different way, especially when you can start seeing what your idea was on paper, then your computer, then in real life, in a matter of, depending on the part, like 30 minutes.
Yeah, to have in a few hours some part that you've designed, and you can see, does this fit? Does this work? Is there something I didn't see about it? Your brain tries to think of stuff in 3D, and then you make it and you're like, oh, this is physically impossible. I didn't realize that, and you haven't had to send a drawing to the machinist and wait a week for it to get made and come back and realize something was wrong. In an hour you go, oh, I'm going to change this. And an hour after that, you've got it changed, and there's things. And it's just completely revolutionized our ability to prototype stuff. And just the fact that we can make stuff like some of these products, like we make, focusing masks and hand controller brackets and just all these little things that we can make that would be impractical to machine, either because the geometry would be difficult or expensive, or you have to make molds and make all these parts and get 1,000 of them, and it becomes it's like, wait, we just want like 6, and you can just have it, so it's amazing.
Yeah and we have optical designs held in by plastic parts just for the first couple tests sometimes, just because
it's like, oh, I need to shim something, I need to make a little spacer. It's like
sometimes our testing is like done on the fly, like, hey, let's change that spacing, let's see if that actually has a real world result.
Change something so quickly. It's absolutely.
I'm thinking like remote work, you can ship that file off to somebody else who you're working with globally and get their feedback, right? Like that's just incredible.
Absolutely.
Yeah. I love 3D printers. They're a ton of fun until they break. Now,
but now they're so cheap, you don't even care so much if they break.
That's true. It is working out a bit.
Team Starizona is clearly leading in last-minute trivia. Will Dave make a comeback? Find out after this short break.
Dive into the world of astroimaging, or level up your skills with the Celestron Rowe Ackerman Schmidt Astrograph, RASA. Thanks to its patented optical design and precision engineering, RASA captures breathtaking images in minutes. Say goodbye to long exposure times and hello to instant gratification. Choose from 8-inch, 11-inch, and 36-centimeter models. To learn more, visit celestron.com/RASA.
So we're coming down toward the end, and so I have one more segment of trivia. So I have 3 more questions for you. And I'll
Who's winning?
They are. Steve is winning. We're all winners. So I've got 3 more, and the first one is, and I'll give the points to whoever gets closest. So not Price is Right rules, Scott.
Oh.
Since 1970. Oh, wait. How many active telescopes are in space right now?
Is that defined as like a scientific research for astronomy telescope, or is any camera lens
I would
considered
say
such a thing?
telescopes looking back at the Earth, or telescopes looking at.
How this?
That's a good question. I mean, I don't have a better answer.
I'm going to go with anything. It could be visible light, infrared, ultraviolet, X-ray, or gamma ray. Yeah. Let's just go with that vague definition.
Okay. I'll give you an appropriately vague answer by picking an absolutely random number. 87.
And so, but it was research kind of based, right? I was actually thinking less if that was the case.
Basically, any space telescope placed into orbit by NASA or ESA. Let's put it that way.
Okay. I might go lower then. Go under.
I was going to go a lot less because I couldn't think of more than like 10. So I was like 10.
I think it's going to be okay.
Like
33.
I'm going to go with 10 because I don't know more, but I'm sure there are.
All right, we've got 10. We've got 33. Dave?
15. Go right in the middle.
Okay. All right. Well, Scott, you said 33, right? You are the closest. 29.
Oh, nice, man.
29. Now, how many can you name? No, I'm not going to do that. But we've got stuff. I was looking at a list of these, and I see, of course, Hubble, right? We've got James Webb up there. We've got Chandra. We've got Iris, the Swift Gamma Ray Burst Exploder. And I'm looking at this list right now, and I'm pretty sure every other one is some sort of acronym. So, but yeah, so we've got 29 basically up there, either in orbit or somewhere in space.
Yeah, cool.
So again, we've been talking about Schmidt-Cassegrain telescopes, right? But of course, those are a combination of two designs, right? The Schmidt camera and the Cassegrain design. What is the difference between the Schmidt design and the Cassegrain design?
I'm an optical engineer, so I know the answer. But
we'll let him answer last. Dave, you're
up
first.
Exactly.
So, I mean, there's with the Schmidt camera, there was a corrector plate primary, and then you had your film in the center. And the classical is just a secondary and your primary, and you don't have a corrector, at least in the front there. So my assumption would be the combination of getting a corrector plate on the Schmidt to have a little better coma correction would have been my guess.
Okay. Dave?
All of the above, and is it correct that there's a difference in terms of the shape of the primary being parabolic versus more
Perhaps.
of
Perhaps.
more of just
I can't
a circular?
tell you for sure.
Not circular. What am I looking for? What's the word I'm
Spherical?
looking for? Spherical, yes.
Parabolic or something? No, I think it would have been. All right, Scott.
So a Cassegrain design, a classical Cassegrain, has a parabolic primary mirror and a hyperbolic secondary mirror, convex secondary. And those shapes are difficult to make, but they're required to eliminate the aberrations in the telescope. A Schmidt camera, which is Schmidt's original design, is an aspheric corrector plate. It's this thin piece of glass with a very specific aspheric curve on it that's so small you can't even see it. But the idea is, in combination with a spherical mirror, it would eliminate the spherical aberration. And like Steve said, in the original camera, it was this corrector plate, a spherical mirror, and then a curved film plane. And so the combination of those is to take the Cassegrain design with the concave primary and the convex secondary, and instead of making them parabolic and hyperbolic, you use the Schmidt corrector plate in front of all that, and both of those mirrors can then be spherical, which is much easier to make if you can make the Schmidt corrector plate, which is a difficult thing for an amateur telescope maker to make, but if you can mass produce it the way Celestron does with their patent on how to make those things and replicate them, which is awesome, then you can make the Schmidt-Cassegrain telescope, which has sort of all those benefits of correcting those aberrations in something that's simpler and less expensive to make.
Very good. 10,000 points to Scott. He wins the game. We are done. We cannot even catch up to him. Well done. Well done.
Bravo.
Yeah. Yeah, I just summarized it as the Schmidt camera had that corrector plate, so then you just add that onto the Cassegrain design and just change the mirrors up a little bit. But what I did for the third trivia question is I asked AI to come up with a better acronym for SCT. And I've got 3 choices here, and I want to hear which one you think is the best one. A, the satisfyingly capable telescope. B, the stellar cosmic tracker. Or C, the sizable clunky tube toy.
I think that's
clearly the best
C all the way.
Yeah. Whatever the most ridiculous possibility is
clunky tube toy is right up my alley.
Yes.
I like that. Well, Scott, you're still ahead with 10,000 points, so you are the winner. Very good. Round of applause. So as we start winding down and we start thinking about the future of astrophotography and the future of Starizona, what sorts of things are on the horizon for you, or what are you predicting, other than more pixels and smaller bins, or whatever you guys were technically talking about? That went way over my head. What kinds of things do you see happening in the future of astrophotography?
More automation and everything becoming easier. Just that's been the trend, is just everything about the hobby has gotten simpler. Astrophotography, like when I started with film, it was just like a nightmare. If you got one picture a month, you were the most excited person in the world, and it wasn't even a good picture. And now if I don't get like 10 pictures on a partly cloudy night, I'm upset. And, so it's just easier for people to get into it who haven't been into it. You used to have to be you had to be an astrophotographer and dedicated to this hobby and learning it and processing and all this stuff. And now just people can go out in their backyard and take these pictures. So that's a big part of it, is just every aspect of it is getting easier and faster.
Yeah, I think there's a introduction of smart telescopes. Celestron Origin's out. There's just you can't throw a camera and not see a bunch of them these days, right? They're popping up like crazy, and then they're just not going to go away. And I think there's nothing really wrong with that. I think the more people that are thinking about the universe and looking up at the stars and learning is better for everyone. And so, you're not going to have a lot of say flat earthers with a smart telescope. You're going to learn things by just being out there and seeing, wait, why isn't the same thing up every night? Well, there's reasons for that, and you start realizing why. So I think smart telescopes, like I said, aren't going to go away. They can get more and more advanced. And so that will be happening. I also think that traditional, what we're doing now, is probably not going to go away, but it's going to change the way it looks and how we're interacting with some of our gear. But I think the idea that a lot of us are kind of modularly putting together pieces of equipment for certain purposes, I think that's still going to exist. But I do think that the barrier to entry is going to get lower for a lot of people economically, and just the concepts and stuff. I have people from brand new young who want to get into this, and then I have people who later in life, older, and both need to learn software and be able to handle it. So I think that we're going to see a lot more advanced software get involved on our phones, controlling the stuff we're using. And
I think from the standpoint of the optics too, the other thing I think of is that it's getting easier to make more complicated designs. It's easier to manufacture optics now, the technology, I can design things now that would not have been feasible to make 20 years ago. And now we can do that. And that's going to improve as well. So you're going to see more sophisticated optical designs that become, reality.
Yeah, that's a good point. We've thrown lots of money down the drain on product or designs for systems that will never see the light of day because we couldn't machine them or polish them to the accuracy that we could design them on ZMAX. And so like reality and what you can do theoretically are two different things right now. And so that's a really good point.
Yeah, but it's improved considerably, really, and it will continue to.
So you kind of alluded to this and circled around it a few times. Rob and I are both teachers. We're educators. We work with young people all day. Are there any things that you can think of that would be words of wisdom to people who are interested in this hobby, would love to make it part of their daily life, and make money while they do their favorite thing? What could they be doing to prepare themselves?
I don't know about how to necessarily make money in this industry. I will say it's a really tough industry to feed your family on, just because it's high volume and margins aren't great. So we stand out in making something. So I guess to that point is like, hey, if you have a 3D printer and you're a hobbyist and you found something that there's a problem you're experiencing, you don't think anyone's, solving, call Starizona and ask us to make it for you, or get a 3D printer, get online, start learning how to code or solder something, and start tinkering. You might just make something really cool, and even if not to make money, just because you're benefiting yourself and people around you that are in the community that can learn from it, and if you get yourself out of your comfort zone, you learn something, everyone's better off. So I think getting out there too, there's a lot of keyboard warriors in this hobby, and it's like, and gearheads who just care about the gear. And I'm part of that group, but I think the magic is when you go outside and look up, and then that's when some of these really big questions start coming in, and just, that you can help, that astronomy and science can help you learn. So I think just getting out there, I think the questions will come, why is that? Why is that this way? Why is it that way? And I think those are the things you just need people to have. And so getting an experience to facilitate that. So, join a astronomy group in your local area, get out to some star parties. They're free, maybe buy some binoculars and a star chart and just kind of get lost. That's my thought, I guess.
Yeah, I agree. Now, one last question. This might take a little bit of thinking here. One last question as we're wrapping up. If you could have 1 hour on any telescope or go to any location for a night of observing, where would you go? And, it doesn't matter. Travel doesn't matter. Anything is possible. Where or what telescope would you use?
I mean, Atacama Desert sounds pretty awesome. High altitude. Scott's been there.
I've been there. No, you gotta dream big. Any telescope. So I have a friend who works at Mount Hopkins Observatory, and he got to look through the MMT, which is a 6.5 meter telescope. So he wins every battle of I've looked through a giant telescope. So I have to be able to top that. So I'm gonna say that when they finish like the giant Magellan telescope that has like the 7-8 meter mirrors that were made at the University of Arizona, and we'll absolutely have no possible way of putting an eyepiece on it. I'm going to go down there and maybe stick some bino viewers on there, and find a way to look through the world's largest telescope. That would be pretty good. Or if you could get a way to look through Hubble or Webb in space, if you can get an eyepiece with long enough eye relief to see through your space helmet, that would be pretty good, because it would be interesting to look through a telescope and not see the stars twinkle. I think would be pretty good.
Yeah, I agree.
I was going to say yet to be developed mirror on the moon, rotating Mercury or something, some weird, crazy design at prime focus, right? I don't know if you guys have ever looked back in the history books, but they used to ride in cages at prime focus, and that sounds so freaking cool. I would love to do that.
The Palomar telescope, 200 inch, there's like guys like up there in the cage.
Yep, that would be my dream right there. On the moon, though.
No. Like a state fair ride or something like that. That's wild. Well, I'll tell you what, Steve and Scott, like, this has been fantastic. We really appreciate you coming on the podcast. We love learning about the engineering behind these things and where you guys are coming from. It's really cool. Thank you so much for joining us.
Thanks for having us. We appreciate
Dave and
it.
Rob. I appreciate it. Thanks a lot.
Fun.
Thanks so much, guys. Really do appreciate it.
Absolutely.
If you're still listening and like this podcast, please consider becoming one of our Patreon patrons. Memberships start as low as $3 per month, with benefits including opportunities to ask questions of our guests. Also, please consider liking, subscribing, and sharing this podcast to help us bring the universe even closer than you think.